The National Electrical Code, or NEC, mandates that cable companies install their own dedicated grounding systems completely separate from a home or building's electrical system. This means cable companies cannot ground their equipment to the meter base, electrical conduits, or the power system's ground rods. The reasoning behind this separation is to safeguard the building's electrical system from potential damage caused by lightning strikes or other electrical surges. By establishing an independent grounding path, the cable company ensures that any errant electrical surges are safely diverted away from the premises' electrical infrastructure. The NEC specifies certain minimum requirements for the cable company's grounding system. Firstly, a dedicated ground rod is necessary. Secondly, this ground rod must be at least 8 feet in length. Thirdly, it must be driven into the earth to a depth of at least 6 feet. Fourthly, the connection between the ground rod and the cable company's equipment must be made using a copper wire. Fifthly, this copper wire must be at least a number 6 American wire gauge, or AUG, in size. The purpose of a grounding system is to provide a low impedance path for fault current to flow back to the source. This low impedance path helps to ensure that overcurrent protection devices, such as circuit breakers or fuses, will operate quickly to clear the fault and prevent damage to equipment and reduce the risk of electrical shock. The ground rod provides a connection to the earth, which serves as a reference point for the electrical system. When a fault occurs, the fault current will flow through the grounding system and back to the source. The low impedance of the grounding system helps to ensure that the voltage in the equipment remains at a safe level. The size of the grounding conductor, in this case the number 6 AWG copper wire, is important because it must be able to carry the fault current without overheating. The NEC specifies the minimum size of grounding conductors based on the size of the overcurrent protection device protecting the circuit. A grounding electrode system, typically a ground rod, is used to connect the equipment grounding conductor to earth. It is essential that all metallic components of an electrical system be properly grounded and bonded to ensure electrical safety. Grounding refers to connecting the non-current carrying metallic parts of an electrical system to earth. Bonding involves connecting these metallic parts to each other to create a low impedance path for fault current. NEC provides detailed requirements for grounding and bonding in Article 250. It covers topics such as grounding electrode systems, grounding conductors, equipment grounding, and bonding of metal parts. In addition to the NEC requirements, local codes and regulations may also apply to grounding and bonding. It is important to consult with a qualified electrician to ensure that all grounding and bonding requirements are met. The goal of grounding and bonding is to minimize the risk of electrical shock, fire, and equipment damage. When a fault occurs, the fault current will flow through the grounding system and back to the source. The low impedance of the grounding system helps to ensure that the voltage on the equipment remains at a safe level, preventing electrical shock. The quick operation of overcurrent protection devices prevents overheating and fires. Proper grounding and bonding also helps to protect sensitive electronic equipment from damage caused by voltage surges and electrical noise. Surges can be caused by lightning strikes, power grid switching, or other electrical disturbances. A well-designed grounding system can help to divert these surges away from sensitive equipment, preventing damage. Electrical noise can interfere with the operation of electronic equipment, causing malfunctions and data loss. Grounding and bonding can help to reduce electrical noise by providing a low impedance path for the noise current to flow back to the source. Proper grounding and bonding are essential for ensuring the safety and reliability of electrical systems. It is important to understand the NEC requirements and to consult with a qualified electrician to ensure that all grounding and bonding requirements are met. It's also worth mentioning the importance of proper installation techniques when installing ground rods. The ground rod should be driven into the earth vertically, if possible, to ensure good contact with the soil. If rocky conditions prevent vertical installation, the ground rod can be driven at an angle no more than 45 degrees from vertical. The top of the ground rod should be buried below the surface of the earth to protect it from damage and corrosion. The connection between the ground rod and the grounding conductor should be made using a listed connector that is suitable for direct burial. The connector should be properly tightened to ensure a good electrical connection. The grounding conductor should be protected from physical damage by routing it through conduit or other protective means. The grounding conductor should be run in a direct path to the equipment being grounded, avoiding sharp bends or kinks. The grounding conductor should be securely fastened to the equipment using a listed grounding lug or terminal. Regular inspection and maintenance of the grounding system is also important to ensure its continued effectiveness. The ground rod and grounding conductor should be visually inspected for damage or corrosion. The connections should be checked to ensure that they are tight and secure. The resistance of the grounding system should be measured periodically to ensure that it is within acceptable limit. A high resistance reading indicates a problem with the grounding system that needs to be addressed. If any problems are found with the grounding system, they should be corrected immediately by a qualified electrician. Neglecting grounding system maintenance can compromise the safety and reliability of the electrical system. It is important to note that the NEC is a minimum standard and that local codes and regulations may have more stringent requirements. It is always best to consult with a qualified electrician to ensure that all applicable requirements are met. The information presented here is for general informational purposes only and should not be considered as a substitute for professional advice. It is important to consult with a qualified electrician for any electrical work or to address any specific electrical concerns. Failure to properly ground and bond an electrical system can have serious consequences, including electrical shock, fire, and equipment damage. It is important to take grounding and bonding seriously and to ensure that all applicable requirements are met. Furthermore, understanding the terminology related to grounding is crucial. Firstly, the term ground itself refers to a conducting connection, whether intentional or accidental, between an electrical circuit or equipment and the earth, or to some conducting body that serves in place of the earth. Secondly, grounding conductor means a conductor used to connect equipment or the grounded circuit of a wiring system to a grounding electrode or electrodes. Thirdly, a grounding electrode is a conducting object through which a direct connection to earth is established. Fourthly, an equipment grounding conductor refers to the conductor used to connect the non-current carrying metal parts of equipment, raceways, and other enclosures to the system grounded conductor, the grounding electrode conductor, or both, at the service equipment or at the source of a separately derived system. Fifthly, bonding refers to the permanent joining of metallic parts to form an electrically conductive path that ensures electrical continuity and the capacity to conduct safely any fault current likely to be imposed. Sixthly, a bonding jumper is a reliable conductor used to ensure the required electrical conductivity between metal parts required to be electrically connected. The NEC also addresses the grounding of specific types of equipment, such as generators, transformers, and motors. These requirements are designed to ensure that the equipment is properly grounded and that any fault current will be safely conducted back to the source. The NEC also covers the grounding of electrical systems in hazardous locations, such as those where flammable gases or vapors are present. These requirements are more stringent than those for general-purpose electrical systems, as the risk of fire or explosion is higher in hazardous locations. In addition to the NEC, other standards and guidelines may also apply to grounding and bonding. For example, the Institute of Electrical and Electronics Engineers, or IEE, publishes standards on grounding and bonding for industrial and commercial power systems. These standards provide more detailed guidance on grounding and bonding than the NEC and can be helpful for engineers and electricians designing and installing complex electrical systems. The National Fire Protection Association, or NFPA, also publishes standards related to electrical safety, including an FPA 70E standard for electrical safety in the workplace. This standard provides guidance on safe work practices for electrical workers and includes information on grounding and bonding. It is important to stay up to date on the latest versions of the NEC and other applicable standards and guidelines. The electrical industry is constantly evolving, and new technologies and materials are being developed all the time. By staying informed, electricians and engineers can ensure that they are using the best practices for grounding and bonding. Proper grounding and bonding is not just a matter of complying with code requirements. It is also a matter of protecting people and property from the hazards of electricity. By taking the time to understand grounding and bonding and to implement it correctly, you can help to create a safer electrical environment. Finally, consider the impact of technology on grounding practices. The rise of sensitive electronic equipment has increased the importance of effective grounding and bonding. Electronic equipment is more susceptible to damage from voltage surges and electrical noise than traditional electrical equipment. A well-designed grounding system can help to protect electronic equipment from these hazards and ensure its reliable operation. Furthermore, the increasing use of renewable energy sources, such as solar panels and wind turbines, has introduced new challenges for grounding and bonding. These systems often involve complex wiring configurations and can generate significant amounts of electrical noise. Proper grounding and bonding is essential for ensuring the safe and reliable operation of renewable energy systems. The NEC has specific requirements for the grounding of renewable energy systems, which must be followed carefully. In summary, the NEC mandates separate grounding for cable companies to protect building electrical systems from surges. This involves dedicated ground rods of specific dimensions and wiring, emphasizing the importance of electrical safety and compliance with established codes and standards.